Here are the solutions for day 3. Question A, factor then simplify. So we have this expression that has this subtraction sign in here separating the first term from the second term. This is called a binomial. And I observe that there is a common factor here and here. So I'm going to factor out the GCF, which is tangent squared x. So tangent squared x times 1 minus, and then sine squared x. Tangent squared x times 1 is this first term, and tangent squared x times the sine squared x makes this second term. Next up, when I see the expression 1 minus sine squared x, it reminds me of one of my identities. Look, over here on the side, we had an identity. It looked like this: sine squared x plus cosine squared x is equal to 1. If you were to subtract sine squared from both sides, what would you get? It would say cosine squared x equals 1 minus sine squared x. So that's going to apply right here. We can replace this with cosine squared x. So that's going to create this next step. Now we're not done yet. We can simplify farther. Let's use the technique from the other day where we replace the tangent function with an equivalent function that has sines and cosines in it. So tangent squared x is equivalent to sine squared x over cosine squared x. And then here's our times cosine squared x. Because we made that substitution, changing tangent into its equivalent expression using sines and cosines, we have some canceling. That crosses out that. And so the final result is sine squared x. This is as simple as we can go because it has a single trig function raised to a power. Question B, let's multiply this out. This is a binomial and it's being squared. Let's apply the algebra technique for doing that. You take the first term and you square it. So that's sine squared x plus, now you double the product of the two terms. So that would be 2 sine x cosine x. And then plus, and now you take that last term and you square it. So that's cosine squared x. Next step, I have a sine squared x and later on a plus cosine squared x. We have an identity for that. What is sine squared x plus cosine squared x? It makes 1, right? The same identity we had discussed earlier. So we can write 1 plus 2 sine x cosine x. At this point, we're finished. There's nothing else that can be done here. Now question C. We want to simplify this adding problem. And these expressions have the look of fractions. Well, we've added fractions many times. We know we need to have a common denominator. It looks like the denominator is going to have two factors in it, 1 plus cosine x and 1 minus cosine x. So to create common denominators, we're going to rewrite. Our first fraction looks like this to begin with, but to have the common denominator with 1 plus cosine x and 1 minus cosine x, we need to multiply top and bottom by 1 minus cosine x. Now plus, and let's work on the second term. It was 1 over 1 minus cosine x. But when creating the common denominator, we need to multiply top and bottom by 1 plus cosine x. In this way, both of the terms being added will have common denominators. Because they have common denominators, you add their numerators. So that's going to be 1 minus cosine x plus 1 plus cosine x. And the common denominator is the 1 plus cosine x times 1 minus cosine x. But those can be multiplied together, and the result would be the difference of squares, 1 minus cosine squared x. Okay, next up. In the top, 1 plus 1 makes 2. And minus cosine x plus cosine x cancels away. Now down in the bottom, we have our 1 minus cosine squared x. But let's put some thought into that expression. We have an identity that within the identity there's a 1 and there's a cosine squared x. I still have it written up here in the very top corner of the screen. What would happen if we subtracted the cosine squared x to the other side? What would it say? It would say sine squared x equals 1 minus cosine squared x. So the 1 minus cosine squared can be replaced with sine squared x. Here is the answer. Now there is one more step that you could do if you want to. Because the sine squared x is down in the bottom, we know that this is equivalent to 2 times the cosecant squared of x. And that does look a little bit simpler, so you could put that as your last answer, but if you got to this step right here, that would also be a good last answer.